Hello and welcome to lesson 57. Today we're going to talk about addition of algebraic expressions with negative exponents. So it's not too long of a lesson, but it can be a little bit tricky. So let's look at example 1. They say to add ax to the negative 1 plus y to the negative 1 and write the answer with all exponents positive. So we can't really add this yet. I can't just turn this into ax to the negative 1, y to the negative 1. That would be completely illegal, not allowed at all. We can't add things together if they don't have the same exact variables. This one has an a and an x, and this one has y, so they cannot be added together. So the first way we can start to attack this by writing all of our exponents positive. That'll make it a little bit easier to see what we have to do. So let's do that. Remember, if I have something like x to the negative 2, to make that negative exponent positive, I have to take the reciprocal of the base, the x, which would be 1 over x, and then keep the same exponent, so it would be to the 2. But now it's in the denominator. So I'm really just popping that x into the denominator, but keeping the exponent, but now it's positive exponent. So I'm going to take x to the negative 1. The a stays in the numerator, but that x gets popped into the denominator. And it would have an exponent of 1. But we don't need to write that because x to the 1 is just 1. So for the second one, y to the negative 1, I take the reciprocal of y, which is 1 over y. And that would be y to the 1, which again is just y. And notice I kept the addition sign in between. That stays exactly the same. So now after making all these exponents positive, it's a lot easier to see what we have to do. We're just adding two fractions. And I can't just make this 1a plus xy, or over xy, because I have to treat this like a fraction. So if I had 1/2 plus 1/3, there's something I have to do first. That doesn't just become 2/5. That would be illegal. To do this, we have to find a common denominator. I would be multiplying this one by 2 over 2, and this one by 3 over 3, to make it 3/6 plus 2/6. And now I can actually add this together, and my answer would be 5/6. So we're doing the same thing, but now we have some variables instead of numbers. So my common denominator, the easiest way to find the common denominator is just to multiply the denominators together. So it would just be something over xy. My common denominator is just x times y. So for the first term, I have to multiply it by y over y, because that's what it's missing to get to that common denominator. The second term, I have to multiply by x over x. So you'll notice that each denominator becomes xy. My first numerator is just a times y, and my second numerator is just 1 times x, which is just x. Okay, so now that we have this, we're getting really close to the final answer. Now that we have a common denominator, we can actually put it together. It just becomes ay plus x, just all those top terms, over my new common denominator, xy. And that right there would be my final answer. Okay, let's try a second one. Example 2. A y to the negative 1x plus b z. So I'm going to start with the same step 1. Write all of my exponents positive. So that a already has a positive exponent. It can stay in the numerator. The x has a positive exponent. It can stay up there. But that y has to get popped into the denominator. We have to give it a positive exponent. That term's done. Let's go to the second one. The second one's all good. We don't have any negative exponents there, so we can keep it the same. But I would write it over 1, so that now we have two fractions. It's easier to add when you can look at it as two fractions. And it's easier to see step 2. We have to find our common denominator again. So if I take my denominators and I just multiply them together, that's y times 1, which is just y. It's a very simple common denominator. So both of my terms are going to be over y. I don't need anything in my first term because it's already over y, so I can just keep it the same. But my second term is lacking in a y, so I'm going to multiply that by y over y. Because remember, y over y is just 1. Anything times 1 is itself, so I can multiply by that. So it'll be b, y, z if I put it in alphabetical order. And now we can actually add it all up because we have a common denominator. Let's add those numerators. That's ax plus b, y, z. And we can't change anything there because there's no variables that are the same. And we can make that all over y. And that would be my final answer. Okay, one last one. Let's see. So now we have a lot more negative exponents. We've got 3 that we have to deal with. We have a to the negative 2, x, y to the negative 1, plus a, z to the negative 1. So let's go through, pop everything with a negative exponent into the denominator. So in my first term, the only thing I have that's positive is that x. So I'll keep that in my numerator. Then let's go to the denominator. We're left with a to the negative 2, which just becomes a squared, and y to the negative 1, which would just be a y. In my second term, the a has a positive exponent, so it can stay up there. And I have to pop that z into the denominator. So now that I have all of my exponents positive, I go to step 2, and I'm going to find a common denominator. So I'll just take my 2 denominators, and let's multiply them together. We have a squared y times z, which just equals a squared y z. That is my common denominator. So let me write out both terms with that new common denominator, a squared y z plus something over a squared y z. My first term is missing a z. So I'm going to multiply it by z over z. My second term is missing that whole other denominator, the a squared y. So I'm going to multiply it by a squared y over a squared y. My new numerator for the term 1 is x times z. And the second one, I have a times a squared y. So I put it over there just so you see what I'm doing. I'm just going to take the a and pop it into there. So a squared y times a just gives me another a, so it'll be a cubed y. Now I have 3 a's and a y. If it was something like this, where it said plus y in between, then we would have to do distributive property. But because there's no plus sign in between, I can just add another y onto that a, so it becomes a cubed y. And now that we have the same denominator, we just put it all together. So we have xz plus a cubed y all over my new common denominator, a squared y z. And that is my final answer. Okay, if you've not yet done the practice problems, try those now. You can pause the video, and I'm going to go over those right now. Practice problem A. X to the negative 1 minus y to the negative 2. My step 1. Make all my exponents positive. So it'll be a over x minus b over y squared. Step 2. Find a common denominator. My common denominator would be xy squared. All I did was multiply it together. Xy squared. So this was subtracting them, which means I'm going to make a subtraction sign in the middle. And I have to multiply my first term by a y squared over y squared. My second term by x over x. So this becomes a y squared, and this becomes bx. I have to put it all together. So it would be a y squared minus bx all over xy squared. Okay, let's go to the second one. A to the negative 3x, y to the negative 1 minus bx to the negative 2. Step 1, make all those exponents positive. So we have an x that stays in the numerator, but that a cubed goes to the denominator, and I have a y down there. Minus b over x squared. And now I can go to step 2, which is find a common denominator. Let me take those denominators for you. We have a cubed y, and I'm multiplying that by x squared, which would just be a cubed yx squared. That is my common denominator. So I'm going to put both sides over a cubed yx squared. Okay. Now what I need on the left side is an x squared on the top and the bottom. On this side, I need a cubed y over a cubed y. Now, if you haven't noticed yet, I'm really just taking this and I'm multiplying this whole side by that. And then I'm doing this and I'm multiplying this whole side by that. So there's a pattern to it. Sometimes you can find a lesser common denominator, but usually it's just going to be multiplying the two together to find that common denominator. So my numerator on the left would be x cubed, because now I have 3 total x's. I have x squared, which is x times another x. So now I have 3 x's. On the right, I have a cubed by. I put that in alphabetical order for you. And then I'm going to have to put it all together, make it x cubed minus a cubed by all over the common denominator, a cubed yx squared. Okay, thanks for watching.